determine the convergence set of the given power series. So that is the power series. What we do here is we're going to use the ratio test. So the ratio test, what we have is we're going to take the limit at n goes to infinity, and we take the ratio of consecutive terms, the next term over this term. So I should say an plus 1 over an. All right. So when n goes to infinity, by the way, if this ratio is less than 1, the series is convergent, meaning that the next term is less than the previous one, that the ratio is less than 1. That's what it means. Right. So we have a sub n plus 1. This is going to be a sub n. So we're going to have, I put 7 on the top, 7 x minus 5 to the n plus 1 over n plus 1 square plus 4 n plus 1, and then divide by a sub n is multiplied reciprocal. I will put 7 x minus 5 to the n at the bottom, and on the top we have n squared plus 4n. I will check the absolute values of that. Alright. So we will have limit n goes to infinity. The 7 and the 7 cancel out. X minus 5, n plus 1 over x minus 5 to the n. N of them cancel out. We have x minus 5 left. And then we have the n squared plus 4n over n plus 1 squared plus 4n plus 1. So we can just say times the limit n goes to infinity of n squared plus 4n n plus 1 squared plus 4 n plus 1. And note that the second one, when we multiply it out, that will be n squared. So let me just write that. We don't need to write everything down, but we know that on the top we have n squared plus 4n. On the bottom we have n squared, and after that everything will be less than n. It doesn't matter, because when we take the ratio of n goes to infinity, only the one with the highest power matters. So that's just like n squared over n squared. So that limit, the whole limit here, will be equal to 1. We can also use the L'Hopital rule, but that limit is just 1. And so pretty much that limit, what we have when n goes to infinity, is just equal to x minus 5. Next, the ratio test say that when x minus 5 have to be less than 1, when we take the ratio of the next term over this term when n goes to infinity, if this one less than 1, it will be convergent. So we say convergent. If x minus 5 less than 1, absolute values x minus 5 less than 1. Now if we solve for that, we should have x minus 5 less than 1, meaning that x minus 5 have to be less than 1 and greater than negative 1. Plus 5 on both sides, we have x less than 6. Plus 5 on both sides, we have x between 4 and 6. Right, so we know it is convergent when x go from 4 to 6. And now we need to test what happened when x equal to 4 and what happened when x equal to 6. So when x equal to 4, if x equal to 4, then the series becomes n equal to 1 to infinity 7 over n squared plus 4n. And then x is 4, so we have minus 1 to the n power. Right. So, by the way, because of negative 1 to the n power, this is the alternating series. And we use alternating series test. Or we can also do this. Notice that 7 negative 1 to the n power over n squared plus 4n. What we do here is, this series is alternative series. That certainly will be less than or equal to what we do here is we throw in the absolute values, which guarantee all of them are positive. Certainly will be greater than when some of them is negative. And if we have the absolute values, of course, negative 1 to the n power absolute values, so this is equal to just 7 over n squared plus 4n. And that one, we can use the limit comparison, that to 7 over n squared. Or we can also use direct comparison test. This one, of course, is less than or equal to 7 over n squared. 7 over n squared, that is the p series when p equal to 2. So let's check. This one is convergent because p series p equal to 2. So that one is convergent. And the next one, because it is convergent, everything less than that is convergent. If it is absolutely convergent, then the series will be convergent. So x equal to 4, the series is convergent. When x equal to 6, we do the similar thing, put 6 in for x, and we just have 7 n squared plus 4n. 6 minus 5 is 1, so we just have 1 to the n power, which will be just 1. Or we don't even need that term. Now this show that, not that, I'm sorry. The series of this term is convergent, so this one is convergent already. So previously we say that x equal to 4 convergent. So here x equal to 6, that also convergent. And so we have convergent when x equal to 4, x equal to 6, and anywhere in between. So the radius of convergence, I should say the interval of convergence. Interval of convergence is 4 to 6 inclusively.